So how do we take everything that we just learned and link it to why you guys are studying this? Okay, so this is your chemistry link to health, enantiomers and biological systems. So many compounds in biological systems have only one enantiomer that's active. And this happens because the enzymes and cell surface receptors on which metabolic reactions take place are themselves chiral, or only one enantiomer interacts with the enzymes or receptors, and the other one is active. And finally, the chiral receptor fits the arrangement of the substituents in only one enantiomer. And so its mirror image does not fit properly. Okay, so what does that mean? Well, if we look at this fun picture, you can see that we have the chiral receptors on the enzyme surface here. But as you know from A&P, enzymes are all about shape. So if the shape does not match the site, well, then it's not going to work. Okay, so you see how the square's on the left here, and square won't fit into a circle, the circle won't fit into a square. But on this guy over here, the circle will fit into the circle, and the square will fit into the square. So enzymes are all shape related. If it's the wrong shape, it's not going to bind, it's not going to do that reaction, and we're not going to be able to have what we were looking forward to happen. Okay, so here's an application of it. So a substance used to treat Parkinson's disease is L-DOPA. You probably have heard about that by now. L-DOPA is converted to dopamine in the brain, and this is going to help raise those serotonin levels that Parkinson's patients have a deficit in. So the enantiomer D-DOPA is not effective for the treatment of Parkinson's disease. Again, it's going to be the wrong shape, so it's not going to fit in there, and therefore it's not going to be able to help raise the serotonin level. So you can see that L-DOPA, remember, is the one that has the group on the left, right, where the D-DOPA is the one that has it on the right. And you can see that it's going to affect shape and therefore application. Okay? So for many drugs, only one of the enantiomers is biologically active because, again, a lot of the applicable reactions in our body are enzymatic reactions, right? So if things are the wrong shape, they're just not going to work. But for many years, drugs have been produced that were mixtures of both the enantiomers. Today, drug researchers are using chiral technology to produce the active enantiomers of chiral drugs. Okay? So that's pretty cool, isn't it?